Hello and welcome to this Python data science project mini series where we will look at the part of a data science process which is data exploration. So this is a data exploration case study which I will be showing you here in this video, where we will be looking at some questions which as a data scientist or as a business analyst or as a data analyst you basically ask when you get any new data, and how to get the answers within the Python is a key thing, because you have to apply a lot of methods, a lot of commands, as well as modify those commands, put the data in structure so that you can get the right metric or the right data visualization in place. So we will look at all this in this one single video so that by the end of this video you have a good comfort zone in terms of exploring any new data by asking the question. So the data set that I have is, let me import and show it to you. So for that I will say import first of all Pandas, because it is an Excel sheet. So we will see how you can import the Excel sheet as well, and import matplotlib.pyplot and in case we need to show the visualization, we will just get this magic command %matplotlib inline, which helps us displaying the visualization just below to the command. So once we have this, what we have is basically a parking data. So it's basically a parking data of United States. So in different states you have the parking within the building or within the open area, and then whether it is owned or leased, that basically a parking data set we have. So let me just in a quick few seconds import it. So pd.read_excel is your method, and in that we have the parking.xls file, which you can get it by going into the description, and as per the instructions I have, you can get the data set. So once I execute this, I have the parking data set, and this parking data set is just here, parking.xls, within the same folder where I have this data exploration case study. So you can simply put it like this so that you don't have to write the entire path like this, right? So parking dot first of all, we would like to explore the first few observations just to understand the data. So parking.head. So what it does is basically shows you the first 5 information or the first 5 rows. So we have all these columns like the building city, the building state, building status, whether it is active or decommissioned, the property type, the total parking spaces, and whether it is owned or leased. Now we can also see the last few observations using parking.tail method. So it shows the last 5 rows to you along with all the columns that is there, right? So one of the things which most of the time you would really like to know is, for example, the building status. Right now it is all active, but what are all the different types of statuses that you have, right? So to do that, what you have is a very good command. So for example, parking, and within that just mention building status and value underscore counts. So what it does is, along with all the columns, all the values that it has within the building status, it gives you their number of count value also. So value counts, as the method is very straightforward. From the name itself you can see that the value that it has within the column, it gives you the counts. So you get the information about what is the active, access, or decommissioned values are there in this entire data set. Similarly, if you want to know the parking property type, so just mentioned property type and dot value underscore counts. counts. And this shows the building structure has the maximum information followed by structure and followed by some open line. Similarly, owned and leased indicates that how the type of the whether the property is owned or leased. So all of this, and total parking space is nothing but the number of parking spaces that it has. So as an exercise, what you can do is you can basically get the building state column and get to know how many building states are over there, or what is the count of building states, and similarly for the building cities, what is the value count over there. So this way you will get to know each and every value that is present in a particular column and what is their relevant count. Apart from this, many times you have a need. Let's say you just keep on working with the data and you are at maybe 17th, 20th or maybe 50th row, where you have to go all the way back up to this particular the snapshot which shows the first 5 or last 5 observation, but you just want to know, okay, how many columns which are present, because you want to use a particular type of column and you forgot basically whether what is a column name. So a simple method that you have is parking.columns gives you the entire information about the columns, right? And this is very useful. This command is very useful because if, let's say, for some advanced process you have to iterate over the columns, you can iterate like this. Just get the parking.columns. This way, let's say if we need to specify the property type, but suppose we forgot, we can simply see, okay, this is the property type, and we can go ahead and see it over here. Otherwise, you always have the method of head and tail, but sometimes, because if you have, let's say, 25, 50, 75 different columns, you will not get the display of all the columns. All right, so let's move ahead and let's try to answer the first question. So right now, if you see, I'm not in edit mode, and if I press 1, it will convert. I'll press 1, it will convert into a heading. So first question is, what is the distribution or values for owned/leased? That means what I'm just trying to understand, whether you have more owned properties or more leased properties, just to understand whether people are taking it as part of their investment or as part of their earning. Owned is more related to the earning that a person is having, and leased is something, you know, they have invested it and give it on the leased and just earning the profit out of it. So what is the distribution of values for owned leased? So for that, what we will have is plt.par, and within that we can mention the x-axis, which is this particular value, owned/leased. So what I'll do is I'll just copy this by selecting it here and putting it here, comma, the y value, parking, total parking spaces. So when I do this, it shows me a bar chart, because it has to work through all the different counts of the value of owned and leased. That's why it will usually take a little bit of time. As you can see, it is, in my case, it is taking some time, but I will show you one more method by which you can first transform the data into the relevant metric, which is like an aggregated metric. It will be displayed in like within a fraction of a second, and then when you will display the bar chart out of it, you will have a much better output in terms of the bar chart. So as you can see, it took like almost 8-10 different seconds to print this value, and it shows that owned is basically having the more count as compared to the leased. So with that, we just got an idea about how the owned and leased property distribution is among the different in the entire US area. So let me just tell you the quick method which I described about. So what we will do is owned underscore leased, and in that we can pass the one method which is pd dot pivot underscore table. Okay, and we need to pass the first of all the object, the parking, that is your source over here, which is this parking, right? And once we have this, we can pass the index as the owned and leased. So I'll just copy that. I'll remove the double quote because it already had the double quotes, and values is its method for basically for total parking spaces. Okay, all right, this is the minimum, but let me just execute this. So I executed, as you can see, in just a doesn't even take a fraction of second to execute it. But if I see how it looks like, own underscore leased, this is how the value basically looks like, leased and owned. And as you can see, the values are very different from this, which is 44 and 74. And it is because if I come over here and expand by pressing shift and 2 times tab, it shows one function which is aggregation function, AGGFUNC, and it indicates mean. So what we can do is AGGFUNC, we can have the count method, and when we execute, it gets 6940 and 2120, or if we want, we can even have the sum, and when we execute, this is the value that we get. So based on what we want, we can basically get the output, and we can then go ahead and display it in a bar chart. So what we can do is owned underscore leased, and we can say simply plot, and here we can say kind equals to bar, and within a second it basically displays the information to us. So what we have used is a different method like plot over here. Instead, what we have used over here is basically the plt.bar. Both the methods are fine. In this case, we are utilizing the inbuilt Pandas capability to plot the data set, and by default it plots line, but we want to plot the bar, so we have just mentioned the bar. So earlier you saw that it took like almost 8-10 seconds, but here not even a fraction of second. You can also use the plt, the plt command that we have it over here, plt.bar. So plt.bar, and what we can have is owned underscore leased dot index and owned underscore leased dot values. And once we execute, all right, it gives an error. Only one size array can be converted into a Python scalars. So it's because we have this. If I just print it over here, the owned underscore leased is having owned underscore leased as an index, and it has just one column. That's why it is throwing us an error. So in this case, instead of values, what I just need is basically the real name of the column, because value will throw an error like this. Only one size array can be converted to a Python scalars. All right, so what do I need is basically over here, and I mention the column. If I execute, I get the chart. All right, so either with this or with this, you can get a similar chart based on what you have. If you see and further observe that the width of the bar is a little bit more, and also the leased and owned is in a different orientation. Here it is vertical and here it is horizontal. So this is based on the basic properties of the library that you are following. So the next question we can explore is in which building state parking situation is in access, and how we can put it in a order. So let me go out of the edit mode, press 1 and write the question number 2, which is in which building state parking situation is in access, put it in a order. So if you see, there is a lot of things which are going on, and you will just get to know and in a minute. And what we need to do is, let's say, first define what we need to do. In which building state parking situation is in access. So the information about whether it is in access or not, I think it is present over here, which is this, the building status, and here is the parking, total parking spaces, and here we have the state. So what we need to do is, we need to create first the pivot table structure by calling pivot underscore table, as I mentioned earlier. So for that, first we specify the parking, then the index, and index is nothing but building state, comma, columns. Columns is nothing but the building status, and you will see that you have a cross table sort of a structure once you will get the output, because index is nothing but a structure like this, where in one column you have multiple values, and columns are nothing but whatever values that are present in building status, which is active, decommission, and access, will come on the columns. And the values is nothing but the total parking spaces, right? We are fine with the mean for now, which is a default. So access underscore parking, and here is our value. So we have lot of active, we have few decommissioned, right, and we have few access parking. So the next thing we may want to do is, since we are only interested in access, we can just remove the not a number, which is the missing values over here. So to do that, what we can do is access parking equals to, we need to have access underscore parking, and in that we say access underscore parking dot over here it's access, so capital access is greater than 0, right? So once we execute this, what do you get? Access parking, if I execute, all the missing values are removed, right? Because we said that we want to filter this entire data set where the access parking is greater than 0. That means all those null values will be removed, and you are now left with only those state where you have the buildings, the active, decommission, access parking, but all the access parking with non-null values. All right, and after that, what you can do is you can just go ahead and plot it. So one simple way is access underscore parking dot plot. If you plot it, it shows a structure like this, which is which we need to say kind equals to bar, and it shows where you have active, decommission, and access. It puts it in a group and clearly indicates you where the parking is in access by having this green line over here, right? And not only this, what you can do is along with this, apart from this, you can also have the plt.bar. But before that, there is one thing which is part of the question. If I remind you, put it in an order. That means do some sort of an sorting in this case. So what you can do is, let's use the plt.bar, right? And in that we will say access parking, right, dot index, and access parking dot values. Okay, so it's the same issue. We just need to mention what we need. Dot access, and this way I am now having only the values which are nothing but the access values over here, but they are not in order, right? So what do we need is basically a simple first of all, the ordering of these values using the sort values method. So let's sort it. Access underscore parking underscore sorted equals to access underscore parking, right, dot we want to sort by the access column, access underscore parking dot access, or it was capital, access dot sort underscore values. So now we have this, and we will just go ahead and, or if you want to see first, let's say access, because you may be interested in seeing what is output. It's a simple output where you have the building state and the access parking in an order, starting with the minimum going till maximum. So with that, now the index and values will properly work, because there is no column which is present. It is a simple series of the building state and their respective value. Access, the PLT dot bar and access underscore parking sorted dot index. Index is nothing but this, comma, access underscore parking sorted dot values. Values are nothing but this. Earlier it was not working because it was a proper pivot table, the Pandas data frame. So if I now execute it, you will see the proper chart. So where you can clearly see a trend or an order which was asked in the question above here. Put it in order. So if you are interested that the sorting should happen, that the maximum value should come first, followed by the smallest value, which usually happen. So here, if I press shift tab, you have a lot of methods, and the parameters. The parameters of interest is ascending over here, or ascending, some people say. Ascending, ASCEN, ascending equals to, and it's boolean, as you can see. So we will say false. If I execute, you will get the different order. So this is a way by which you can simply answer the question, which is this, and we saw the different scenarios in which we need to follow to come to the logical conclusion. But in a real life, once you will get to know all of this value, it will be just a matter of seconds, or you may even develop the functions which will give you the output like this. So let's move ahead and look at another question. So the third question that I have for you is the building cities that have been decommissioned along with total parking. Okay, so let me write this by pressing 1. Let me 1, and over here, third is building cities that have been decommissioned, right? And that has to be in the view of a total parking that was there. So that's why along with total parking. You can probably better frame it than this, but what I want to see is decommissioned parkings in the building cities. So once I go ahead and execute this is the information. Now I have it here, and what you can do is you can probably pause this video and try it on your own and come back. Otherwise, you can follow along with me. So let's go ahead. And for that, what I'll do is first let me see the information about the data set, because I feel it's very useful when we are trying to answer a question like this to understand building cities that have been decommissioned. So building city is here. Decommissioned status is over here, and if you remember, can you answer that how you can figure it out? What are the values that are present within this column? And it is an interview question as well. It can be an interview question as well. So I hope you have got it, how you can figure it out, the building status and all the values which are present in the building status. And we just have to look at the decommissioned. So what we'll do is we will simply filter the decommissioned parking. So we'll say decom underscore parking underscore city equals to parking and within that parking. So building status, because we need to only get the decommissioned building, right? Come out of this equals to DECOMMI decommission. I hope I have written it right. So just to tell you what is going on over here, within this data set, wherever this value is true, so the output of this value is the evaluation. Either it can be true or it can be false. So wherever it will find true, it will return the output. Otherwise, the false will be thrown out. So this is like filtering. So now we go ahead and see decom parking city, and you see all those cities where the parking has been decommissioned, the building status is decommissioned, and it has the respective values. So now it's very clear that we have the building city which is Overland and the building city which is St. Louis, and both the property types were owned and they have been decommissioned, and the total parking space of 2089 and 357 has gone. Now it is a matter of research that why this has happened, what has really caused this. Along with that, we see that in other cities also the parking has been decommissioned, but there was no parking spaces, so still makes sense. But Overland is a major cause of worry, probably because you are losing 2000 parking spaces. Now, as part of the exercise, I want you to only filter those decommissioned cities where the parking space is greater than 0. If you remember, we did it in the last exercise. So let me not repeat that. But for you to do an exercise, just get these two rows out of this entire data set and then plot it, right? This will give you a good hands-on exercise. All right, so the next question is, in which type of property parking space is in access? So let me write this. Press 1 to put it in a heading. In which type of property parking space is in access? And I will just say 4 over here. Execute this. So as I always do, parking dot head, just to get the data, in which type of property, so that is property type over here. So as you can see, questions usually don't say that a particular column or something. Once we see the data, we should be able to interpret what the question is saying or what the business is asking, and we need to say parking space is in access. So access should be present over here, the building status, as we have seen previously. So we are only concerned about this column, and this column, right? These 3 columns is something where we are concerned. And here I will show you a method which will help you to basically optimize the process of filtering and pivot table and everything into just one single statement. All right, so we will say access underscore parking underscore property, and within that pd dot pivot underscore table, and here we will have parking. Within that we will say parking and building status equals to access, because we want to know only that building status where the parking is in access, right? So and next we have index equals to property type and values equals to total parking spaces, and after that should be closed, right? So what is going on here? Where we need to specify the pandas object which contains the data frame, we are saying to that object that only give us those values or those rows where the building status is in access. So let me go ahead and execute it. Worked fine. Access underscore parking underscore property, and this is basically those two structures. The building and the structure is basically the two values where the parking the status is saying that it is in access. So you can go ahead and visualize this, or you can report it, or you can further look at the question like, okay, now I have got the property type. What are those states, right? Our next level of question. And within that state, what are those cities where it is in access? And then what you can propose it to the management, maybe by looking at the overall parking area. Wherever the parking is in access or parking is underutilized, you can go ahead and propose some strategies around it, which is a part of the business person about after getting the information like this. Okay, so let's move on and answer the next question, which is by pressing 1. Let me answer, say 5. Where is more active parking? Where is more active parking? So active parking is basically present here, and where is a very large word. I mean, it can be building city, it can be building state, it can be property type, it can be owned or leased. So sometimes if it is not given, you need to ask the question about it, that what are the dimension you need to get this information by, because we have like these 4 different dimensions, or it can be 20 different dimensions. So answer, let's say we get, is owned/leased. They want to see the information by owned, leased. Okay. So as always, let's start to see the columns. Active parking is here. Parking spaces are here. Owned and leased parking is here. Alright. So what we will do is we will create an object, active underscore parking. We will write pd pivot underscore table. I hope by now you have become an expert into this, right? And that's the motto I had in mind, that along with the visualization, answering the question, you become an expert into this particular method, because you will use it a lot. Alright, so parking is, we have building status, and we only want the active parking. So I will write active, and it has to be in caps, as it is mentioned over here in caps, right? And index equals to owned/leased, and values equals to total parking spaces. Some error, syntax error, invalid syntax. Fine, we closed this, and we have to close one here. Okay, still, because this is here. Alright, simple error. So now on an average, these are the 2 parking spaces that you have. So usually on an average you have more parking spaces in the owned parking. So this is an average. Remember, you have the total parking spaces. So if I press shift tab, you have the aggregation function mean. So you should interpret it right, that the more park on an average, you need to start with this. On an average, the owned parking has, or owned type of parking has, the more parking spaces as compared to the leased parking. So that's your overall observation where the parking status is active, right? Now let's add some twist to this, and I would like to let some brainstorming from you. However, I will show you the solution. But let's say the next question is that along with this, they want to know the proportion as well, because businesses really understand the numbers well when they are interpreted in percentages. So how you can find the relative percentages, that okay, if this is the total that you have. So for example, if I say active underscore parking dot sum, it should give me the total, which is 119, right? So out of 119, what is the percentage contribution of this? What is the percentage contribution of this? So how you can do that? Well, it is very, very easy. One part I have already shown you over here. So why don't you go ahead and try it? Well, just pause the video and try it out. I know you will get an error, but that's a part of brainstorming to figure it out how to do it right. So I hope you have figured it out the solution, but if not, let's go ahead and try it. So active underscore parking, And we cannot apply it on the entire data set because we have both like owned, leased, total parking spaces for the active. We need to specify on which particular column we need this contribution. So that is your total parking spaces divide by active parking, again total parking spaces dot sum. That is your method to figure it out, the percentage contribution. And if I execute, you get 37% is this, 74% is, or sorry, 62% is this, 74. That's what it represents. How about adding this up? How can you add this particular values which you have got? Because right now, if I say active underscore parking, nothing is coming out, right? So how you can add it? So why don't you pause the video and try it out? Well, if not, then let's go ahead and let me see percentage contri, which is contribution. And what we are doing is we are creating a column over here by specifying like this, right? And I'll just copy this. That's all. And if I say active underscore parking, so you have percentage contri, whatever you want. I mean, that's just one quick short form of contribution. But 44 represent 37%, this represent 62%. Now one can ask, okay, I want to multiply it by 100, I want to format it in a percentage. Go ahead and do that. It's very easy. All right, let's move on to our next question. And I will say 1 and then 6th, which is states with more leased parking and with more, or similarly with more owned parking. So whether it is more leased or more owned, if we know the one answer, we will know the another answer in a similar way. States with more leased parking. Let's say business wants to do as a research over there and wants us to basically figure it out, this solution. So how we can do that? Well, let's start with the information like this, where we have the parking with more leased parking is over here, and this is the total parking spaces, and this is our state information. So we will go ahead and create a table which is state underscore leased underscore parking. We want to know the leased parking, right? So it should be straightforward. I want you to pause this and do it on your own, and I hope you have done it. But if not, I would like, why don't you follow along with me? Owned slash leased equals to leased, right? Because this is the column in which we want only the leased part, right? And index is nothing but your state, because by state information we need, and the values is nothing but total parking spaces. No brainer, right, by now, because we have already seen everything. So that's why I'm moving a little fast. I'm not explaining this. So state underscore leased underscore parking. All right. So states with more leased parking. How do I know more? Well, I need to sort it, right? And how do I sort it? I have already told you. So why don't you do it on your own and come back with the answer? So, and I hope you have done that, but if not, then sort underscore values. That's the method, right? I've just added it to this data set that we just created in the form of a pivot table. So total parking spaces and the parameter, remember, ascending, false. So these are our top five status. So MO, I think Maryland or some, and then Texas, then I guess VA and AL. I'm not very familiar with the states in the United States, so sorry about that. But TX, I can clearly identify that it is nothing but the Texas. Okay, so these are the top states that you have. So which basically gives us the output states with more least parking. How you can get the top 5 states? That's my question to you. Well, by now you should have got it, because I have not asked you specifically. However, I have done it like almost 6-7 times, the number of times I have asked the question. If you remember, the head, right? So this is how you can get the top 5. So I'm not showing you that information, but you can go ahead and experiment with it. That's what the data scientists usually do, all the experiment all the time. Now let me ask you another question, which is the question number 7. The question is, which property type has more active parking? Which property type has more active parking? I hope by now this has become a no-brainer to you. I want you to follow the methods which I have shown in my previous 6 questions and answer this, and let me know in comments that what problem you are facing if you have not got it. Let me ask you another question, right, for the exercise. Question number 8. How is the distribution of parking in city by property type? Just trying to give you a different perspective, but try to answer it. I have talked about a little bit about the distribution above. It's not the statistical distribution, but just an understanding of the total parking that is available in city by the property type. By now you should have got a very good idea. And next question is, if I say, or probably the last question is, building states which has 0 parking spaces. Building states which has 0 parking spaces. All right. So these are the few questions. The last 3 questions, I would really like that you figure it out and try to understand how you can figure out the answer of all of these. Should be straightforward by now when I have explained you all of that different stuff, or the methods, or all the information like the pivot table, the bar chart, and filtering and whatnot. So this should help you answering these 3 questions. And last but not the least, some very crucial information like how you can figure it out, the maximum and minimum from a data set. So let me put it in a question, which is the question number 10. What are those states which has maximum and minimum parking space? That means a state which has minimum parking space. In this case, we can see like ND, and maximum parking space, but this is based on owned and leased, MO. But how you can utilize, or how you can figure it out, this particular question. Now this is something I have not explained in this video, and I would really like that you explore a little, right, or figure it out. One way is, let me give you a hint, that one way is use the slicers, and with the slicers just extract the first and the last value after doing the sorting. Very straightforward, right? And then or what you can do is, to print the state's name, you have 2 methods like idx max and idx min. See what you can do with that and figure out the answer. I have given you 2 hints, so now you should be able to do it. So let me know what your thoughts are about this exercise. What do you want to see more in such exercises? Your comments really helps me to better understand and create more meaningful videos for you. And I hope you have found it useful for your data science data exploration task, which is very important exercise that one has to do, or one experimentation one has to do to better understand and explain the data. So that's about it. Do share it with your friends and colleagues, and I will meet you in the next video.